So let's see memory leaks in action. In the last video, we sort of try to like build an intuition around memory leaks. In here, we'll create a simulation of it so that we can sort of correlate both the situations and see what it looks like in the browser. If you haven't seen the last video, I will link it somewhere here and you can go have a look. Yeah, so let's get started. So here I have just created a simple UI or a simple sandboxing environment where what I am doing is I'm doing this. So I have a create button. When I click on the create button, it creates a grid with a huge number of squares. Every square gets a random color, and every square has event listener. So whenever I'm hovering over it, so it's mouse over and mouse out. So it's sort of used to create the hovering event. So it is listening for hovering events. So whenever someone hovers over it, it will show a tooltip of what color is it. And when you move the mouse out of that square, it will remove that tooltip, right? Tooltip is basically a small indicator on the top. You'll just see it in a while. And then the next function we have is, so basically we create the layout and we append it to the child, right? So we just inject it in the DOM, that's what. Then the next thing we have is the remove button. And when I click on it, I'm just setting the latest row display as hidden. So it's a CSS property we are setting. So we want to remove the entries, the latest one as we added. When I click on remove, so I chose this example because I see this mistake a lot of times. So I thought it would be a good way to demonstrate it so that it stays there. And then basically what we are doing is whenever we are adding something, we are adding things, whenever we're removing something, we are removing from the end, right? So that's what. Then let's start with this. Let's create a grid. We have this, right? So this is the grid. We created one grid, and when we hover, we see the colors. So those were the listeners we discussed in like a while back, right? The listeners will show up. And then we create another grid. We create another grid. We create another grid. We keep on creating. Then we remove them, right? So all of them. That's what. So the latest one is removed, and we reach the initial state. So ideally, it's like you can sort of correlate to the water situation, right? So you can take this current state as a full glass of water, you redistribute it among glasses of different sizes, and then remove it can be you recollect all of them, and you're back with that state, right? Full glass of water. And if you don't have full glass of water, or if you don't have the amount of resources that you started with, you have memory leak. That's an indication of memory leak. There can be a lot of things here. It's a very like oversimplified use case. You could be maintaining some state which you need for later, which any of those we aren't doing here. So yeah, in those cases, that might behave differently. But in this case, if it should be the same, the initial and the final one, right? Since we are not holding anything and we don't have anything to do with the data we collected, right? So yeah, let's go to performance and let's see. Reload the page and let's start recording and see what's the resource consumption here. So in 5 seconds we trigger a garbage collection so that everything is clear from the beginning. We start creating grids, we create more grids. We are just redistributing the water as we discussed in our analogy in the last video, right? So it's similar to that only. So every block has its hover event. It's showing the random color that it was getting assigned, and then we start recollecting the water or removing the grid in our use case. So we are removing them, and yeah, we are done recollecting. Now let's trigger garbage collection so that everything unused is, we get rid of everything and let it run for 5 seconds so that we have enough padding on the end, and then we stop it. Interesting, right? So you see here, you start at this point, and this was the UI state. You allocated some things, you allocated resources, you remove them, but you see the memory is always increasing. It's not decreasing anywhere, maybe once or twice here and there, but not much. Same for the listeners. So they never decreased, right? So it never got garbage collected, even if we triggered one manually. So when you see these yellow blocks in this line, these are garbage collections. So if you zoom in, you will see it's called major GC, if you can read it. So these yellow lines are garbage collections. This one was the one we triggered right before stopping the test, but it did not collect much. like the starting point was still this point, and the ending point was way above the starting point, so it's still consuming resource and you're not using them here because you don't need them. So what's the mistake here? So we discussed something about reachability, so how garbage collector score is reachability. So if something is reachable, it won't be garbage collected. So if this is happening, you maybe intentionally or maybe by mistake has made something still reachable. So what is that? So when we say unreachable means you cannot access it anywhere in the future even if you want to. So it's basically you don't need it. We don't need it here as well, but we maybe did some mistake somewhere which sort of ended up making it reachable, and the garbage collector is like, okay, the user is saying that they might need it in the future, but you actually don't need it because it's something that you communicated, it's something that you did not communicate well, right? So yeah, so that's what we'll try to understand in the next video. In this video, I just want to demonstrate an example of garbage collection, what it might look like. And in the last video, as we discussed, starting state, full glass, redistribution of water, recollection of water, should return to here, but it didn't. So there is some leakage somewhere, so that's the memory leak, right? So yeah, that should be it for this video. In the next video, we'll see what was the mistake and we'll try to fix that, and we'll calculate again based on those, right? So yeah, if you like the video, please share it with your friends, drop a comment. If you have any feedbacks, leave them in the comments. And yeah, see you folks. Bye.